In this lecture, I will introduce several network topologies, but first several definitions. A network is a collection of interconnected stations. So we have here several users, several stations, and we can communicate between them using a network. Stations or users are devices that network subscribers use to communicate. At a particular station, we can send signal as well as we can receive signal. A node is a point where one or more communication lines terminate. So we have between stations, we have several nodes where lines can terminate and split. For example, from this station, we can communicate through these two nodes to this station or using different nodes to different stations. And a trunk is a transmission line that supports large traffic loads. So communication line for large traffic load is called trunk. The topology is a logical manner in which nodes are linked together by information transmitting channels to form a network. The most common topologies are T-network topology, bus topology, star topology, ring topology, mesh topology, and hybrid topologies. On next several slides, I will detail these topologies. Star topology. Star topology has several stations or units and a single node called host. So all connections between different users are through a single node. T topology. We have a single bus, a single line, and many users tapped to this. Bus topology is similar to a T topology, only here we have stations or users from both sides of the main line. Ring topology. We have several users connected sequentially in a closed loop, forming a ring. Mesh topology is a special type of a network where any station, any user could be connected to any other user on demand by establishing a point-to-point link. For example, if we want to connect a video interworking with this video interworking, we can establish this connection shown here by a dashed line. And if we want to connect those two stations, we can establish a different communication point-to-point link. On this slide, I show a collection of different topologies. Star topology we discussed, ring topology, mesh topology, bus topology, and several more topologies that we will briefly introduce here, but will not discuss in more details later. Tree topology, line topology, and a fully connected network where we physically run connection between each and every node in the network. Also, the networks can be divided into several broad generic categories depending on the distances, on the length of the links in that network. And we differentiate between a local area network, LAN, access network, metro area network, MEN, and wide area network, WAN. The local area network, the shortest links, interconnects users in a large room or work area, a department, a home, a building, an office or a factory complex, or a group of buildings located nearby. An access network encompasses connections that extend from a centralized switching facility to individual businesses, organizations. And a metro area network, length of the links up to 50 kilometers, interconnects facilities ranging from buildings located in several city blocks to an entire city and the metropolitan area surrounding it. It's where the name came from, MEN, right? Metro area network. And the longest connection is wide area network connection with the length of the links beyond 50 kilometers. It spans a large geographical areas The transmission distances can range from links between switching facilities in neighboring cities or cross-country, terrestrial, or intercontinental undersea lines. The large collection of WAN resources is owned and operated by either private organization or telecommunication service providers. On this slide, we have a reiteration in writing of what I just said on the previous slide, so I will go to the next slide right away, and you can use it for further references to differentiate between 4 different types of networks, depending on the length of the links. We can normally relate different network segments to different network topologies. For example, typical long-haul communication is using T or bus topology. Typical WAN, wide area network segment, will use star topology. And for MAN and LAN, metropolitan area network and local area network, typical network topologies would be a ring. But of course, there could be some deviations. For example, on this slide, a global network is shown. Looking at the interlocation of different switches and nodes and trying to identify different network topologies, we can see that, for example, on the right, we have a ring here. Obviously, going to the left, we have a star connection here, another star connection here, and another star topology here. Another example is a regional network shown on this slide, and we are trying to identify different network topologies. So we can see one example is this black line in the middle, long-haul link. That is an example of a bus or T topology. Also taking into account this central regional hub and its connection to blue nodes. Together we have here a star topology, but also we can see that blue nodes are interconnected by a second set of lines together, forming a ring topology. And the last example of this kind is the metro network shown on this slide. Obviously, we have different nodes connected in a sequential manner, forming a loop. So effectively, we have here a ring topology. As for transmission distances, I already mentioned before, but want to underline it here again, that for long-haul and wide area network links, the distances are typically hundreds of kilometers, 600 to 1,000 kilometers, and for metro and regional networks, it's much shorter, of the order of 10 to 200 kilometers.